Are you looking for a video on how to differentiate terminating decimals from non-terminating decimals? Then this video is right for you. So, without much further ado, let's begin. Hi, my name is Rowel Carpio, a math teacher and a coach, and I do math tutorial in my YouTube channel. In this video, I'm going to present to you how to differentiate terminating decimals from non-terminating decimals. So what is the difference between terminating and non-terminating decimals? Decimal numbers with fixed number of digits after the decimal point are called terminating decimals, while decimal numbers without fixed number of digits after the decimal point are called non-terminating decimals. Non-terminating decimals can either be repeating, also known as recurring decimals, or non-repeating decimals. In repeating decimals, a digit or a sequence of digits in the decimal part keeps on repeating itself indefinitely, while non-repeating decimals do not have a repeating pattern. So let us have examples. We have here sample number 1 is the decimal equivalent of 1/4 terminating or non-terminating decimal. So the first thing that we are going to do is to get the equivalent decimal of the given fraction 1/4. So for us to get the decimal equivalent of 1/4, we have to divide our numerator 1 by the denominator 4. So 1 divided by 4 cannot be, so we are going to put here 0. So 0 times 4 is 0. 1 minus 0 is 1. After that, we have to add as many zeros as needed in our dividend, but provided we have to put first the decimal point. So decimal point and then we have 0. So bring down 0. 10 divided by 4 is 2. 2 times 4 is 8. 10 minus 8 is 2. And then we can add another 0. And this 0 will be brought down. So 20 divided by 4 is 5. And 5 times 4 is 20. So 20 minus 20, we have now 0. So the decimal point in the quotient is directly above the decimal point in our dividend. So in other words, the decimal equivalent of 1/4 is 25 hundredths. So since we have a fixed number of digits after the decimal point, so meaning to say that the equivalent decimal of 1/4 is a terminating decimal. So let us have example number 2. We have here is the decimal equivalent of 5/6 terminating or non-terminating decimal. So first we are going to find the equivalent decimal of 5/6. So in order to find the equivalent decimal of 5/6, we have to divide the numerator 5 by the denominator 6. So 5 divided by 6 cannot be, so we have to put here 0. So 0 times 6 is 0. 5 minus 0 is 5. And then we are going to add decimal point so that we can add as many zeros as needed. So 0. And then we have to bring this 0 down. So 50 divided by 6, we have 8. 8 times 6 is 48. 50 minus 48 is 2. And then we can add another 0. So bring down this 0. 20 divided by 6 is 3. 3 times 6 is 18. 20 minus 18 is 2. And then we can add another 0. Bring down the 0. So 20 divided by 6 is 3. 3 times 6 is 18. So 20 minus 18 is 2. So if we notice that this process will continue endlessly. So meaning to say that the digit 3 is being repeated endlessly. So meaning to say that the decimal equivalent of 5/6 is a non-terminating decimal. And since the digit 3 is repeated endlessly, the decimal equivalent of 56 is a repeating or recurring decimal. And the digit that is being repeated is 3. That's why we can write the equivalent of 56 in decimal form as 0.83, and there is a bar above the 3 to tell us that the digit 3 is a repeating digit. So let's have example number 3. We have here is the decimal equivalent of 2 and 1/8 terminating or non-terminating decimal. First is for us to find out the decimal equivalent of 2 and 1/8. Since 2 is the whole number in the given mixed number, so meaning to say that the digit 2 is also the whole number in the equivalent mixed decimal. The next thing that we are going to do is to find out the digits after the decimal point by dividing 1 by 8. So 1 divided by 8 cannot be, so you have 0. 0 times 8 is 0. 1 minus 0 is 1, and then we are going to add zeros after the decimal points. So 0, bring down 0. 10 divided by 8 is 1. 1 times 8 is 8. 10 minus 8 is 2. So another 0. So bring down the 0. 20 divided by 8 is 2. 2 times 8 is 16. 20 minus 16 is 4, and then another 0. Bring down the 0. 40 divided by 8 is 5. 5 times 8 is 40, and 40 minus 40 is 0. And the decimal point in the quotient is directly above the decimal point in our dividend. So meaning to say that the decimal digits are 1, 2, and 5. So meaning to say that the decimal equivalent of 2 and 1/8 is 2 and 125 thousandths. So since we have a fixed number of decimal digits or the digits after the decimal point, so meaning to say that the decimal equivalent of 2 and 1/8 is a terminating decimal. Let's have sample number 4. We have here is the decimal equivalent of 9/11 terminating or non-terminating decimal. First is for us to identify the decimal equivalent of 9/11 by dividing 9 by 11. 9 divided by 11 cannot be, so we have 0. 0 times 11 is 0. 9 minus 0 is 9, so we have to put decimal point so that we can put as many zeros as needed. So 0, bring down the 0. 90 divided by 11 is 8. 8 times 11 is 88. 90 minus 88 is 2, so another 0. So bring down the 0. 20 divided by 11 is 1. 1 times 11 is 11. So 20 minus 11 is 9. So another 0. Bring down the 0. 90 divided by 11 is 8. 8 times 11 is 88. And 90 minus 88 is 2. So another 0. Bring down the 0. 20 divided by 11 is 1. So if we notice that if we will continue the process, it will give us a repeating pattern. So the decimal point in our quotient is directly above the decimal point in our dividend. So we have here a repeating pattern of 81. So meaning to say that when we write the decimal equivalent of 9/11, it will give us 0.81 and so on. So meaning to say that the bar is directly above the digits 8 and 1 because 8 and 1 are the digits that are being repeated endlessly. So meaning to say that the decimal equivalent of 9/11 is a non-terminating decimal and at the same time is a repeating or recurring decimal. So as a recap, we have here decimals can either be terminating, for example, the decimal equivalent of 1/4, which is 25 hundredths, and non-terminating decimals. Example here, we have 1/3, that is 0.33 because the 3 is being repeated endlessly. For non-terminating decimals can be categorized into two. We have here repeating or recurring decimals. For example, 9/11, that is equivalent to 0.81, and 81 is being repeated endlessly. And we have also non-repeating decimals. Example of non-repeating decimals, the equivalent value of the pi, which is 3.1415, and so on. So there you have it, how to differentiate between terminating and non-terminating decimals. I hope that you have learned and enjoyed watching this video. See you again in my next video. Thank you.